Hello, welcome back to the channel. So let's continue our previous video and do one more problem on evaluating indefinite integrals using substitution and also using the integration by parts formula in order to fully calculate the answer to such type of questions or such type of integrals in this case. And again, in order to solve these type of questions, the first step is to identify the pattern, which will convince us to use substitution rather than following any other method to calculate this indefinite integral over here. So again in this question we have to calculate the integral of e to the power cos x times sine 2x dx. So in this question we see a sine x component, a sine component. It's sine 2x but we can adjust it, right? So we see a sine function and we also see a cos function, and we also know that both the functions are derivatives of each other. So if we can somehow manipulate this indefinite integral using substitution and can simplify this indefinite integral, we will be able to easily solve this question, right? So now, and we also know a property of sine 2x. We know that sine 2x is indeed 2 sine x cos x because of the double angle properties of sine functions. So now, if we have to again write this integral, simplify this integral, we can write this integral as simply integral e to the power cos x 2 sine x cos x dx in this case, right? There is a dx over here as well. And now, as we did in the previous videos, let's adjust these components individually and put them into right place so that it's easier to visualize the substitution that we will do in this case. So we can write this as simply, we can take the 2 out, and this can be written as e to the power cos x sine x dx in this case, right? And we know that if we somehow can assume our u function to be cos x, we know the derivative of cos x, which is minus sine x. So if u is cos x, we know that du will be minus sine x dx, and we have a sine x dx component over here. So that is why in this case it gives us an idea that if we assume a u function to be cos function and use substitution, we can definitely simplify this integral into a simpler expression over here, right? So now let's do that. Again, I'm going over it quickly because we have already covered all these concepts in the previous videos. So if you have not watched my previous videos on substitution, I would highly suggest you to first watch those videos in order to get the full idea about this question and why we chose to do substitution in this case rather than following any other approach to solve this indefinite integral over here, right? So now we'll assume our u function to be cos x. And in this case, if we take the derivative of u with respect to x, this would be minus sine x. If we shift the dx to the other side, so du would be minus sine x dx in this case, and we have a sine x dx component which can be easily changed to minus du over here, right? Because in this case, if I shift the negative sign to the other side, it would be minus du equals sine x dx over here, right? And now let's change this integral expression over here. So I'll copy this expression down, and this would be, so we have this expression over here. We know that our u function is cos x, so we can change every occurrence of cos x with u, and sine x dx will be changed to minus du in this case, right? So it would become 2 times integral e to the power u times minus du over here, right? And now again, in order to solve this, we can take this negative sign out. So now we have to solve 2, indeed negative 2 integral. Let's rearrange this. It would be u times e to the power u du in this case, right? And now we already know from the knowledge of our previous videos that in order to solve this type of integral, we assume the first function. We always, in these type of questions, when you have a polynomial function and an exponential function, and you have to calculate the integral of this combination of two functions, you'll assume your first function to be the polynomial function and the second function to be the exponential function in this case, and then use integration by parts approach in order to solve the indefinite or definite integral in these type of questions. So again, our first function is u, our second function in this case is e to the power u, So we'll use integration by parts in order to solve this indefinite integral, and this would become minus 2 times first function as it is, integration of second minus differentiation of first, which is 1, integration of second e to the power u, and then integration of this whole expression. So again, once we solve this indefinite integral, we'll add the constant of integration. So the answer would become u e to the power u minus e to the power u. And then when we have solved this expression over here, we will add a constant of integration at the end because we are calculating an indefinite integral over here, right? But now again, from the knowledge of our previous video, we know that this is indeed not the final answer. The final answer in this case will be formed when we will change every occurrence of u to the original function, because in this question we were integrating with respect to x, right? With respect to the variable x. So we want the final answer to be in terms of x only, right? So that is why, since in this case we assumed our u to be cos x, we'll change every occurrence of u to be cos x in this case, right? So the final answer in this case would become negative u cos x e to the power cos x minus e to the power cos x plus the constant of integration in this case. So again, that's it for this video. The basic idea about these type of questions is to first identify the pattern, which will convince you to use substitution before doing the integration by parts formula in order to fully solve these type of questions. Because if you'll straight away use integration by parts formula in this approach, in this indefinite integral, it will make your calculations much complex in this case as compared to the case when you'll use substitution first and then use integration by parts in order to solve these type of indefinite or definite integrals. But again, the thing that you have to keep in mind, the very important thing that you have to keep in mind is whenever you're changing your original integral expression to a new integral expression, you have to again, and in the final answer, you have to again change every occurrence of your new function back to the original function in these type of questions. That is why in this case, when we calculated the final answer in terms of u, we had to change every occurrence of u back to the original function, which was cos x in this case, right? So I hope that makes sense. Feel free to comment down in this video if you have any doubts related to this concept or related to any specific component of this video as well. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.